Hi guys, and welcome to another lesson. Today we are focusing on one variable equations level 2, which means we are going to up that challenge a little bit today. And instead of doing just one step equations, we're going to add in 2 steps. So it's going to get a little bit more challenging, but we're going to use that same knowledge that we learned in the last video in order to solve the equations in this video. So let's go ahead and get started. Before we get started, I wanted to remind you of some of this algebraic vocabulary, and I also wanted to show you an example of a 2-step equation, and that's on our screen here right now. In this equation, we have a coefficient, which is multiplying our variable, and we also have an added constant. So we're going to need to figure out what to do with that constant in order to still solve for x, or that unknown variable. So now that we're adding in that constant, we're going to have to do something that goes against everything all of your math teachers have ever told you. And we're going to have to go against order of operations. But we're not going to completely shift around the order. We're just going to follow it in reverse. So instead of first figuring out what we need to divide by on either side or multiply by on either side, we're going to start at the very end and we're going to work with the addition and the subtraction first. So what that means is I'm going to subtract out this 9 from both sides before I deal with that coefficient of 3. Now, just like we did in the last video, whatever we do to one side of the equation, we also need to do to the other side of the equation. So let's start with that adding a 9. And the way we get rid of it to get x closer to being alone is by subtracting it. And I want to subtract it from the sum or the total as well as from the side with the variable. When I subtract out that 9, I'm left on the left side of the equation with 3 times x, or 3x. And on the right side of the equation, now I have 33. So I'm not done yet, but now we have an equation that looks really similar to what we were doing in level 1. We have this multiplication type equation where we're going to solve using division. So to get x by itself, or to get x with a coefficient of 1, we need to now divide both sides by 3 to figure out what our variable is equal to. And we're left with x is equal to 11. But we're not done yet. In the last video, we did a lot of work with checking, and we need to really especially check our work when we have these 2-step equations. But now when we go to check, we need to remember to use order of operations to make sure that our answer is correct. So let's go ahead and see what that looks like. So to check our work, we need to remember what we found our solution for x to be. And in this case, it was 11. So now what I'm going to do is I'm going to rewrite the whole entire equation, but instead of putting in x, I'm going to replace x, or substitute out x, for what we found it to be, which is 11. So let's rewrite this equation. And I've used parentheses here because if I just wrote 311, it would look like 311. So I put parentheses here, but you could also put a multiplication dot or a multiplication sign. However, now that we're working with algebra, which is math with letters, I don't like to use the x or the traditional multiplication sign. I prefer to use parentheses or the dot, the middle dot, to show that multiplication so we don't get confused and think of that times or multiplication symbol as another variable. So now that I've rewritten it, I'm going to follow order of operations to solve, which means I need to multiply 3 times 11 before I add that 9. So when I multiply 3 times 11, I'm left with 33 plus 9, and then I can add to get 42. And 42 equals 42, and we have that balanced equation. Let's try another example. So remember how I said we were upping the challenge with level 2? Well, in this equation, it's going to look like a level 1 equation. It's going to look like a 1-step equation, but I'm adding in something extra, and hopefully you'll notice when you see it. Our equation is 54 equals 8 minus x. Again, it looks like a 1-step equation, but it's actually not. We have 2 steps here now. And I'll show you what I mean in just a second. The other part of this equation that's different is now I have the variable on the right side of the equation. We can see the variable on either side, so we just need to be mindful that we're still going to try to get that variable by itself. So what we're trying to work with here is that 8 and not the 54. So we're going to follow our reverse operations, our reverse order of operations to solve this, and I'm going to get rid of that 8, or that constant that's sitting next to our x. And that's a positive 8. There's nothing in front of it that's signifying that it's a negative 8. So since that's a plus 8 or a positive 8, we're going to get rid of it by subtracting 8 from both sides. And when I do that, I'm left with 46 equals negative x. We haven't dealt with that subtraction symbol yet. So this is what makes this type of problem 2 steps, because now I need to get a positive x. I don't want to know what negative x is equal to. I want to know what positive x is equal to. So we've got to do a little bit of something extra here. And even though it doesn't exist in our problem, we have this invisible coefficient of 1. 1 times x is going to give us x. So we can think of this as an invisible negative 1 times x. So to get that x to be positive, I need to divide out that negative. So I need to use my integer operations here. When I divide a negative by a negative, that's going to leave me with a positive. So I'm going to divide both sides by negative 1. And when I do that, it's going to leave me on one side of the equation with negative 46, and on the other side, a positive x. Does this look right? Well, let's check our work to find out. All right, so let's go ahead and check our work, which means we're going to take the value that we found for x and replace the x in the problem with that new value. So I'm going to rewrite the equation, and now I have 54 equals 8 minus negative 46. And here again come our integer operations. We need to have a really good understanding of how to subtract negative numbers in order to be able to check our work with something like this. So when it comes to subtracting a negative or subtracting integers with negative numbers anywhere in the problem, I like to remember the keep, change, change rule, because I always think it's easier to add negative numbers than it is to subtract negative numbers. So when I keep, change, change, what we're doing is we're keeping the 8, we're changing that subtraction to addition, and we're changing that negative into a positive, which is going to leave us with this equation here, 8 plus 46. And when I do that, I'm left with 54 equals 54. It might be helpful to go back and review addition, subtraction, multiplication, and division with integers, especially if you're starting to see them come up in algebra and those algebraic equations. It's really important that we still follow all of those rules that we've already previously learned. Let's try another example problem. All right, here we go. We're going to up that challenge one more time. And this time, I'm going to include a negative number, and I also have that fraction, which, as we learned in the last video, is telling us to divide. So here I have negative x fifths, or negative x divided by 5 plus 12 equals 6. Just like we did in the previous examples, I'm going to follow reverse order of operations to find for x, or to solve for x, which means I'm going to first deal with that 12. I want to get rid of that constant first. And whatever I do to one side of the equation, I need to do to the other side. So I'm going to subtract 12 from both sides of the equation. And when I do that, it's going to leave me with negative x fifths, or negative x divided by 5, equals negative 6. From here, I have a very standard division problem, but I want to deal with that negative. I want to get out in front of that negative and get rid of it while I can. So since this is a fraction, I can, when I go to multiply out that 5, I can multiply by a negative 5, and that's going to remove that negative symbol from in front of my x. But whatever I do to one side, I need to do to the other side. So I'm going to multiply both sides of the equation by negative 5. When I do that, that's going to leave x by itself on the left side of the equation because a negative multiplied by a negative is going to give me a positive. So I'm left with x, and on the other side, I'm left with 30. Are we right? Well, let's check our work. All right, here's our equation. We are going to replace that x with the 30 that we found, but we can't replace the negative symbol. So we're gonna leave that in there when we go to rewrite the equation, and we're just gonna swap out the x. So now we have negative 30/5, or negative 30 divided by 5, plus 12 equals 6. We need to follow order of operations when we're checking this. So the first thing we're gonna do is we're gonna divide negative 30 by 5. And when I divide negative 30 by 5, I'm dividing a negative by a positive, so it's going to stay a negative, and it's going to stay a negative 6. So now on one side, I have negative 6 plus 12 equals 6. And when I add together my negative 6 and my positive 12, I'm left with 6, and 6 equals 6. So now that we've done a few examples together, I want you to try some of these two-step equations. Before I show you the two practice problems I have for you today, I want to remind you of two things. The first are those inverse operations. We have the opposites of addition and subtraction, and multiplication and division. The other thing I want to remind you of is that we need to use reverse order of operations to solve for the variable, and then we need to use order of operations to check our work. So we've got two steps here that are really important to remember. Here are two example problems. I'd like you to go ahead and pause the video and work through these problems by yourself, and then press play when you're ready to check your work. Let's start with the problem on the left-hand side. Since we're going to follow reverse order of operations to solve for C, we're going to deal with that minus 19. And when we do that, we're going to add 19 to both sides. And when I add 19 to negative 21, that's going to leave me with negative 2. And on the left side of the equation, I'm left with 2 times C. We want to get C by itself, so we're going to divide out that 2 from both sides, and I'm left with negative 2 divided by 2, which means that C is equal to negative 1. Now when I put this back into my equation, I'm left with 2 times negative 1 minus 19. 2 times negative 1 is negative 2. So now I have negative 2 minus 19, which is going to leave us with negative 21. Let's look at the other problem. W divided by 6 plus 8 equals 38. Using reverse order of operations, we're going to subtract out that 8 from both sides, leaving us with W divided by 6 equals 30. From here, we need to multiply both sides of the equation by 6 in order to get W with that coefficient of 1. So 30 times 6 leaves me with 180. When I go back in to check, what I'm left with is 180 divided by 6 plus 8. 180 divided by 6 is going to give me 30. 30 plus 8 equals 38. So that's it for our level 2 video, where we've added in a second step to our one variable equations. In the third part of this series, we're going to bring in word problems, and we're going to use word problems with those two-step equations. So we're going to learn how to write an equation from a word problem and then solve it using the knowledge we learned in this level 2 video. That's it for today's lesson. Thanks for watching, and I'll see you in the next one.